I have prepared these lecture notes, What is a Norm, to support 6.1.2, in which in our course, which is linear algebra, have dealt with norm in the L2 Euclidean sense. However, norm is a very general concept, and in the concept of algebra or modern algebra, or sometimes called abstract algebra, norm actually is a function from a vector space V over the real and complex number, such that the function returns a non-negative real number that satisfies some properties, and the properties are as follows. Let us discuss the properties of norm first before we go and discuss what is a function and what is the word over the field of real or complex number. Let's focus on this notation, which is often used to describe norm. P is a function, and the colon means such that. V here means the vector space, and the right arrow here means a function that gives an output a real number. The real number, in addition, is a non-negative value, and the vector space V is over a field of F, and F is typically the real number or the complex number. Let's talk about the properties. The properties of the norm are these. If U and V are elements of the vector space V, and A is the element of the field, then the norm P of U plus V is less or equals to P of U plus P of V. This property is the triangle inequality property. Basically, it means that a norm acting on the sum of U plus V is less or equals to the norm acting on U alone plus the norm acting on V alone. The second property, which is the absolute scalable property, or sometimes called the absolutely homogeneous property, says this. The scalar A multiplied by V, and we take the norm of this AV, is equals to the absolute value of the scalar A multiplied by the norm of V. And the third property, positive definite, or being the norm giving always positive value, and only gives the zero value when the vector V is the zero vector. These are the three properties that is needed to be called a norm on V. In our course for linear algebra, we typically deal with only the Euclidean norm, or sometimes called the two norm. And the norm is the length of the vector, and this is the square root of the inner product, or in our case, the dot product. However, in abstract algebra, norm is generalized to vector space and field. Hence, a vector space equipped with a norm has a name called norm vector space. Let us now revise what is a function. The typical definition of a function notation looks like this. F is a function such that it takes an element from X and change it to an element of Y. Both X and Y are sets. Sometimes we use the word, the function f maps element of x to the elements of y. And one of the rule of function says every element of x must have exactly one element in y. Now we go back to the first page. What is a norm? And it says a norm is a function from a vector space over the real and complex number. What does over the real or complex number field means? In our linear algebra, our vector space are the space of R2 and R3. And the scalars, for example, alpha, betas, are real numbers, or sometimes complex numbers. In the alpha and beta of R3, the alpha and betas are real numbers. Briefly, the first point of vector space over the field K, where K is the real or complex, means that the elements of the vector space can be added together in a cohesive way. So we are now talking about vector space of V here, but in addition to that, the vector can be multiplied by the scalar K. And K belongs to a field, and field here means that it is a set that not only can we add or subtract, but we can also multiply and divide. So K is an element of a field, and typically in our example, it is the field of real or complex numbers. All these are very abstract. However, if you are more interested to understand this area of work, I would like to suggest to look at abstract algebra under Socratica. They will define what is a field, and they will also define what is a vector space. Thank you.